Here I'm again using WaveMason in order to simulate a 100 ohm transmission line that's fed by 100 ohm source impedance. I have effectively one 50 ohm transmission line, and that feeds into a 33.3 ohm resistor. So when I start my simulation, my 2 volt source is actually voltage divided across the 100 ohm source resistance and the 100 ohm source impedance. Now, when I transition to the 50 ohms, I have a 0.333 volt reflection off of this junction, so that 1 volt minus the 0.333 volts gets me the 0.667 volts that you see right there. And then as this wave bounces around a little bit more, ultimately you see this stabilizing towards the 0.5 volts that you would expect if you had a 100 ohm actual source resistor feeding into a 33.3 ohm load resistor. Remember that the transmission line is actually just wires, and at DC you really just have the 100 ohm resistor and the 33.3 ohm resistor in the circuit. It's only when you're looking at this in the transient sense with the voltage waves bouncing around that you get the differences. Now, I can also run a digital signal through here, and you can see what these voltage waves do to a digital signal when you have mismatched lines. You could easily see that there would be bit errors going on if you're actually this mismatched from your digital source to the digital receiver.